Hello, thank you for joining me on this class. We want to look at how to differentiate the exponential function. The exponential function is the inverse of the logarithmic function. Thus, if we have a function y equal to exponent x, then if we take logarithm to base e of both sides, we will have x is equal to log y base e, and the y dx, that is the derivative of y with respect to x, will be equal to d dx of exponent x, and that is equal to exponent x. So this means that if we have a function f of x equal to exponent x, then the derivative f prime of x is also equal to the same function exponent x. Now we will look at some examples on how to differentiate the exponential function. The first one, example 1, is to find f prime of x if f of x is equal to exponent x squared plus 5. Now the solution. Our function f of x is equal to exponent x squared plus 5. Now if we differentiate, we will have exponent x squared plus 5 multiplied by 2x. What have we done here? We have differentiated the exponential function itself to get exponent x squared plus 5. Then we multiplied it by the derivative of the exponent. The exponent is x squared plus 5. So when you differentiate x squared plus 5, you will have 2x. So that is why we have exponent x squared plus 5 multiplied by 2x. And that gives us 2x exponent x squared plus 5 as the derivative of that function. Okay, let's go to the second example now. We have example 2. Find the y dx if y is equal to exponent sine x. Now you see we have a function of a function here. Y is a function of exponent sine x. So our solution is y is equal to exponent sine x, then dy dx is equal to exponent sine x multiplied by cos x. Cos x is gotten from differentiating sine x, which is the exponent itself. So that's why we have the derivative to be exponent sine x times cos x. So that gives us cos x exponent sine x as the answer. Okay, we have another example, the third one. Find find dy dx if y is equal to x raised to power x. Now what are we going to do here? Let's solve. Y is equal to x raised to power x. Then we will take logarithm of both sides to base e. If we take logarithm of both sides to base e, we will have ln y is equal to ln x raised to power x. Ln means logarithm to base e. Okay, so the right hand side can be written as x ln x. The power x comes down here to give us x ln x. That is just one of the rules of indices that we applied here. So we will differentiate both sides now with respect to x. So that will be d dx of ln y equal to d dx of x ln x. The left hand side, we will differentiate it as an implicit function, while we will use the product rule to differentiate the right hand side. So on the left hand side, if we differentiate ln y, we will have 1 over y dy dx. And on the right hand side, if we apply the product rule to differentiate, we will obtain 1 times ln x plus 1 over x multiplied by x. You can see that the last term here on the right side, 1 over x times x, will give us 1. So that if we multiply through by y, which is the coefficient of, which is the inverse of the coefficient of dy dx, we will have dy dx is equal to y into ln x plus 1. So we have a value for y. We will remember that y is given to us as x raised to power x. So if we substitute that value of y into this equation, we will obtain dy dx is equal to x raised to power x multiplied by ln x plus 1. So that is our result. That is the derivative of that function which is given to us. And we're going to end this video here. You can practice with this exercise. Find y prime if y is equal to exponent sine 2x plus 1. Thank you for watching this video. Please don't forget to like and share, and also subscribe to this channel.